Alrighty, so we are starting our Michigan Stoich Lab today. This is a fun one. It takes 2 days to do this lab. So we'll be doing this, same thing with the scuba goggles and the aprons tomorrow, so make sure you grab those. We're working with particularly nasty stuff, a lot nastier than anything we've worked with so far this year. Hence the extra protection. We want to make sure you guys are super safe. We don't have any potential accidents. The aprons are necessary. In fact, in one of our chem classes last week, we had someone spill 6 molar hydrochloric acid and it flew off the desk and actually hit them. But luckily they were wearing the apron. It hit the apron, just slid right off, and they were good to go. If they had had their regular clothes on, they would have had to ditch those regular clothes right there on the spot. So it was great that they were wearing their apron, right? So we want to make sure we are super safe. You'll need your pre-react table out, of course. Let's go ahead and talk about what we're doing in this lab today. So you guys are looking at this handout right here, okay? So this is the actual experiment that you guys will be doing today. I'm going to walk you through it. So you are going to take some sodium bicarbonate. That's what NaHCO3 is. And make sure you guys got your phones away because there are a lot of instructions. And I don't want to have to repeat myself too much here. So you're going to be doing this experiment. So you're going to start with sodium bicarbonate. Here it is right here. Okay, it's going to be in little beakers in the back. And hydrochloric acid. So, what's up? My name is Partner A. Partner A, you're going to grab your beaker at your station. There's probably a couple. You just need one of them for today. You'll need a couple tomorrow. But you want to make sure it's nice and dried out. So if yours isn't quite all the way dried out, you want to make sure it's nice and dry before you start. Because that will goof up your results quite a bit, actually. It's kind of surprising how much that will throw off your percent yield at the end. So make sure it's nice and dry. You're going to go back there. You're going to get, it says measure 0.5 some grams of your solid. Now, when I say 0.5, that means somewhere in that neighborhood. So if Layla gets 0.47, great. If Abdullahi gets 0.56, that's fine too. Just whatever you actually get, please make sure you write that down. So write down exactly what you got, and it should just be somewhere close to 0.5. Okay? So, when you're back there, here's what you're going to do. You're going to take your beaker. You're going to hit what? 0. You're going to put your beaker on there. You're going to write that down right there. You are going to press the 0 button again. Okay? So that way, you're telling your valve, hey, now I've got the math out, I'm just going to say that now that's 0. And you're going to add about 0.5 grams. And here's how you do that. You just kind of tap, tap, tap. And you give it a second to catch up. You won't need that much, probably some along these lines, okay? It's not that much. And if you hit 0 that second time, that way, you don't have to calculate anything. You can just see exactly how much you're putting in. And then partner A, you're going to go to a water station, okay? And you're just going to turn on, you're going to kind of wave it in there. You don't want too much water. You want about, look how it says, approximately 10 milliliters. You don't need to measure the water by any means. You just want to get about halfway up to that first line where it says 20. Here's why. You just want to get all the kids swimming at the pool. So just kind of swirl it a little bit. You just want everybody swimming, floating around. That's all you need. Okay? It's not going to dissolve all the way. You just want to get it nice and swirled up. Okay? What's up? I'm Partner B. Partner B, you're coming up here. You're going to grab 1 vial of bromothymol blue and 1 vial of 6 molar hydrochloric acid. This acid is the really nasty stuff. You absolutely need to have those goggles on, the hair tied back before you come up here and grab this. Okay? So this is what can really hurt you today, if used improperly. You guys will meet back up at your station, okay? So one partner is going to get a full squirt of bromothymol blue, like this. Oh, I just accidentally hit my tile button. Stop that. There we go. One little squirt of bromothymol blue, just like this. And then while one partner swirls, the other partner is going to add hydrochloric acid in here drop-wise. So just, why does it keep doing that? I keep hitting my keys, I think. Shut up. There we go. Okay. I don't know why I did that. Anyways, so you're going to add bromothymol blue drop-wise like this while one partner swirls. And eventually the color will change. You see how it's changing already? It should get to a point where it looks like this. It's sort of like the I worked out today and didn't drink enough water color. Okay, something like that. You'll then place this on your Bunsen burner. You're going to get that puppy cooking. You're going to heat it up.
How many drops to put in there?
Just till it turns yellow. You don't want to add too. You want to just have the minimum amount of acid until it turns yellow. If you dump a bunch of acid in there, it'll turn yellow right away, but that'll goof up your results. So you just want to barely get it to the point where it's yellow. Does that make sense? Just keep dropping until it goes yellow. It's different for everybody. You're just going to hit this with heat for a while. Eventually, you'll hear like a crackling kind of sound. You're getting close to the end. You're running out of water. When you hear that, you can grab your Bunsen burner at the bottom. I'll even show you guys. I'll go ahead and light this guy here. Okay. You can grab your Bunsen burner at the bottom while it's lit. That's fine. And if it's crackling towards the end, you can just sort of wave it like this. Be a little bit more gentle, because some of your product is going to try and jump out of that beaker. You'll keep heating it until it's completely dry and it looks something like this. Okay? So yeah, it's totally dried in there. So we have no water left. Okay, nothing's falling out of there. It's nice and dry. Now, if at some point during the lab your beaker turns back to blue while it's heating up, because that could happen, here's what you're going to do. You're going to take it off with your beaker tongs. One partner will swirl it like this, and the other one's going to add drops of hydrochloric acid until it's back to yellow. And then you just continue to heat. Okay, so wherever it does turn blue, take it off, hit it with a little bit more acid, and you're good to go. Okay. Now, when you are at this point where your beaker looks like this, you're going to take it off, you're going to plop it right here. What are we not going to use today? How have we been cooling down our crucibles before? How do we cool them down?
Wet towels.
Wet paper towel, okay? We absolutely cannot do that today, okay? That glass will shatter. Glass can't change temperature that quickly like metal can. It will just shatter on you. So you're just going to plop right there on a countertop. This countertop soaks up heat really well. Just let it do its thing for a few minutes, okay? Eventually, you're going to kind of move the pot closer, kind of test it out. If it's cool enough for your paw, it's cool enough for your balance, okay? So you'll get that final mass. You will write that down here. You'll get that final mass, okay? And then here's what you're going to need to do. Partner B is going to return your vials. Partner A, look at this beaker, see how much salt's in there? Just a little bit of water will take care of all of that. You're just going to rinse it out. It just immediately cleans up super easily with water. Rinse it a few times, and then dry it out real nicely for the folks who are going to start this lab next period, okay? Once that's all done, make sure you wash your hands at the end of this lab. You really don't want to walk out with anything extra on your paws today. That could be very problematic for you later. You can go ahead and start working on your calculations. So calculation 1 is definitely the hardest, and then 2 and 3 aren't so bad. And I'll kind of walk you through those guys. But number 1 is the toughest one. It's a mass-to-mass calculation, just like your quiz from last week. Okie dokie? So we're just doing reaction 1 today. You guys will do 2 and 3 tomorrow. Same idea. Do I have any questions? Our goggles are on, our hair's tied back, our aprons are on, and we are rolling. Okay, let's go ahead and talk here. I'm really going to walk you guys through the calculations for today because we're going to go through this lab tomorrow where it's a little bit trickier, but you'll have done it once already, and so that'll be a nice advantage for you tomorrow. Okay? So, here's our situation. We took sodium bicarbonate, that's NaHCO3. So that's what you got about 0.5 grams of. You got about 0.5 grams of. So we then added hydrochloric acid, that's HCl, and we made NaCl, CO2, and H2O. Now let's think about what should be in that beaker at the end. CO2, what is that at room temperature? It's a what? It's a gas, right? Is that going to stay in that beaker? Nope. So that went off into the air. What happened to the H2O? What did we just do to it? Yeah, we boiled that away, so that also went off into the air. Okay? So the only thing that should be in your beaker at the end is NaCl. So all that salt that you guys had at the end, that should just be NaCl, whatever it is, however much you made. Because everything else goes into here. So when you get your mass at the end, you can actually figure out exactly how much NaCl you have, because the CO2 and H2O should be long gone. Okay. Now, notice the wording on this. It says calculate in theory. You guys see how it says in theory there?
Is it balanced?
Oh, that's a great question. I'm so glad you asked. We should make sure this is balanced. Why don't you guys take about 30 seconds? Make sure to balance this for me if it's not already. Okay, so you should find that this is actually already balanced. So there's one Na on both sides. There are two H's on both sides. One carbon, three oxygens, and one Cl. Because remember, like, you have three O's at the end of sodium bicarbonate, but you have two in carbon dioxide, and that third one is in H2O. So this one's already balanced. Will that always be the case? Usually not, but sometimes equations just come out balanced as they are, which is nice. Again, you should always look both ways before you cross the road. That doesn't mean there's always a car coming, but you better always look. Okay, in the same way, you always double check to make sure something's balanced before you move on in your chem. Okay, now, look at number one. It says, in theory, theoretically, this is a, quote, perfect world. So, this is how many grams of sodium chloride should be formed. Question number one is asking you if everything went perfectly. You got just the right color yellow. It never went blue. You didn't add so much hydrochloric acid at the end that you made it too yellow. You didn't have a single grain of NaCl jump out of your beaker, which almost all of you guys did. But in a perfect world, let's pretend none of those things happened. If this went perfectly, how many grams of NaCl should we have? Okay, so that's what we mean by theoretically. That's if everything goes perfectly, what should happen? See how it says should right there? What should form? So, we're asked about sodium chloride, okay? Grams of sodium chloride. So we're asked about this guy right here. Where are we starting now? Where are our calculations starting with? That's where we're going. That's what we want to know at the end, but where are our calculations starting? We're starting right here, okay? So if that's the case, we're going to calculate how many moles of NaHCO3 we had at the beginning. What's the equation for moles? Moles equals what? Mass over formula weight. Okay. Here's what we're going to do. Now these numbers I'm revealing right here in red, these are my numbers. Please don't use these. These are mine. Yours should be similar, okay? But please don't use my numbers. Use your numbers as you go through this. So I personally started with 0.52 grams of sodium bicarbonate. So I'm going to plug that in for my mass, 0.52. You put in your mass there. So if you got 0.60, that's fine. Just write that there. If you got 0.47, that's fine too. Write whatever you got for that number up top. So mass, or moles equals mass divided by formula weight. What is the formula weight for NaHCO3? I got 84 as well. You took one sodium plus one hydrogen plus one carbon plus three oxygens. Adds up to 84. And I calculated 0.0062 what? 62 moles of what? Of sodium bicarbonate. Because I took the mass of sodium bicarbonate, I divided it by the formula weight of sodium bicarbonate. I now have the moles of sodium bicarbonate. So let's get everybody to that step real quick using your numbers, okay? Let's put about 60 seconds on the clock. Alrighty. So I'm going from here to here in this equation. What kind of ratio is that? That is 1 to 1. So what do you do to make a 1 to 1? You multiply it by 1, whatever. You don't do anything, however you want to think of it. So that means that 0.0062 remains 0.0062. What are my units now, though? It is NaCl, but like grams of NaCl, moles of NaCl. It's moles of NaCl now. And take a look at your arrow. Look, you even said, hey, I started sodium bicarbonate. Now I want to convert it to NaCl. So your unit should change to reflect that. So see how we're talking about NaCl here? That should change to go with that. Okay? Now, I want to solve for the mass of my NaCl. It's just like the quiz we took last week before we headed out for that long weekend. So moles equals what again? Mass over formula weight. I don't know what the mass is, so I'm just going to put X grams, or maybe Layla wants to put the word mass, and Eli wants to put a little m for mass. However you want to do it. That should be your variable you don't know. And my formula weight, oh, okay, I already found it earlier. That should be 84, right?
No.
Oh, that's right. 84 is the formula weight of NaHCO3. I'm not talking about that anymore, am I, though? I'm talking about NaCl. So what should that formula weight be? Yeah, I got 58 because I took 1 sodium, which is 23, plus 1 chlorine, which is 35, and I got 58 there. Hey, what do I do to both sides to find my grams? Yep. So for me, that would be 0.0062 times 58. I got 0.36 grams of what? Grams of NaCl. That's what I got. Here we go. So in a perfect world, if nothing went wrong, I should get 0.36 grams of NaCl if everything went perfectly. We know that almost never happens, so we're going to figure out how perfect things did or did not go. I'll do a quick pause real quick to see if you guys get reasonable numbers. Alrighty, so let's go ahead and calculate this real quick. So what was your experimental? So this is their mass that you actually got during the experiment. This isn't the perfect world scenario. This is, hey, how much did you actually make? You were supposed to make 0.36. How much did you actually make? So you're going to take the beaker at the end with your product in it. What am I going to subtract from this? Your empty beaker at the beginning. The only difference between those two, because the carbon dioxide and the water are in the air, should be how much you actually made. And I'm going to put my units on there, grams of NaCl, and box it up, of course. All right. So I'll be honest with you. Question number 1 is by far the most work, and then questions 2 and 3 are pretty straightforward after you nail question 1, which takes a lot of work. Okay. So percent yield. What percent successful were you? And this equation will be on your lab handout tomorrow. You take your experimental. That's how much you actually made. For me, that was 0.32. You will compare that to how much you should have made in a perfect world. That's your theoretical. So theoretically, in theory, how much did you make? I should have made 0.36. Another way to say that would be your answer to question 2 divided by your answer to question 1. You will multiply that by 100% to change it into a percent. So 0.32 divided by 0.36 for me. I got 8.888 repeating. I multiply that by 100, I get 88.8 repeating. So I'm just going to call that a good old 89%. So I'm rounding to my closest whole number. So I was 89% successful. I wouldn't be surprised if a lot of you guys are in the 80s or even 90s, because this first reaction goes the best. Now here's the deal. Tomorrow, you will do this same reaction twice, since you're kind of used to it. You're going to do reactions 2 and 3, which are the next pages, so keep this lab. And on Thursday, we're going to have a quiz over this lab. Mr. P, what will this quiz look like? This quiz will have these 3 numbers typed on a lab handout. And you will have to calculate the exact same questions 1, 2, and 3. It's the same exact thing as the lab. It's just I'm going to give you the numbers as if you had done the lab that day. I can't remember off the top of my head. So probably in between 10 and 15. Most quizzes are in that range. All right. That's a wrap for today. I'll see you guys next time.